Darn. Shoot.
Okay, so we're going to start section 3. So section 3 is all about hypothesis tests. So chapter 9, we learned about confidence intervals, which are panics. Hypothesis tests are phantoms, and they're used kind of to answer the same type of question that a confidence interval is. So we are going to learn the testing procedure. We're going to talk a little bit about the connection between a hypothesis test and a sampling distribution. We're going to talk about p-values. Just so you know, hypothesis tests and confidence intervals make up 40% of the AP test. So last year's test, I think it was, out of the 6 show your work questions, 2 of them were hypothesis tests. 2 out of 6, so a third of them. So that's kind of a lot. So this is really important. What you guys have first is what phantom stands for. So write it down and then we're going to talk about each part. So P stands for parameter. This is exactly the same as in panic. Let mu equal, let pi equal. H are the hypotheses, so the null and the alternative. And just, I guess you write and then we'll talk. Okay, I'm not going to write, I'm just going to talk now and then we're going to do an example. So like I said, P for parameter is the same thing as P in panic. So let pi equal or let mu equal. H is the null and the alternative. It's what we've been doing the past few days. You're going to write the null and the alternative in symbols and then in words. The assumptions are exactly the same as for a panic problem. Exactly the same. Naming is pretty much the same. You're going to have to tell me what the name is. You're going to have to tell me what table you use. And then for panic, you told me 95% confidence or 90% confidence. That's not how it works for a hypothesis test. For a hypothesis test, you use alpha, the significance level. So you'll tell me alpha equals whatever it is. The test statistic is a formula. An output or a diagram, that is the normal curve. Making a decision means I'm going to reject or fail to reject. And then stating your conclusion is you're actually going to write out, I fail to reject, which means this. Okay. I think it's best if we just jump into an example. Yeah?
Sure.
Okay. I need you guys to stick with me through this entire example. Not only is this pen very frustrating to use, but it's also a long problem. So can you guys stick with me through everything? Sure. On a positive note, it's a pretty interesting example. So this is what you guys have on the next page. It's about this woman named Kristen Gilbert. So Kristen Gilbert was a nurse in the Veterans Administration Hospital in Northampton, Massachusetts. To some, she was a lifesaver. To others, she was a power-hungry egomaniac.
She looks happy.
She looks happy?
I actually can't tell.
Okay, so you guys don't have this, but let's look. So these are the deaths by shift. So night shift, day shift, and evening shift. What do you notice about deaths by shift?
Evening.
Occur in the evening.
Okay, a lot occurred in the evening. Always in the evening, though?
From years 91 to 95.
Okay, so 91 to 95, it looks like most of the deaths happened in the evening. But 88 to 90, it looks like maybe day, night, it kind of fluctuates. Okay, so let's see when she was on duty.
Huh. Sounds interesting.
Huh. So it just happened that we switched from night to evening as soon as she switches shifts.
Coincidence? I think not.
Okay, well, so some people started to notice this and say, you know what, there happens to be a lot of deaths on the shift when Kristen Gilbert is working. Do you think that there might be a connection, that maybe she has some relationship to that? And so she was actually tried for murder. She was brought to court, obviously, and they analyzed the statistics just like we're going to do now. They did a hypothesis test. So we're going to do the same hypothesis test that they did in court. This is the data that you guys have on page 17. So it lists how many deaths there were on that shift and whether or not she was present. Okay. Okay, I'm going to have to write, so you guys are going to have to keep the numbers and I'm going to write on a white screen. Is that okay? Yeah, Miss Bond, that's okay. Okay. Thanks, guys. It's really helpful. Very helpful of you all. Okay. So we're going to start with P. Oh, man. Starting out good already.
Try right in the middle of the screen.
There you go.
Try writing. That doesn't make a difference.
Hey,
Well, see?
It seems to be depends on the bank at the bottom.
The pen is on ink. Okay, let's see.
it's not trying.
Okay. Oh my gosh, I don't know if I have the patience for
It's like
this.
a P and an L.
You know, just go with it, okay? So P, we're gonna look at proportion. So today we're just learning a hypothesis test for proportion. So we're gonna let pi be the population proportion of deaths when Gilbert is on shift. Okay, that's just a fancy way of looking at Gilbert's death rate. Okay, you have to make sure, one, that you use the symbol pi, one, that you use the word population, that you say proportion, and that you use context. Okay, so when they did this in court, they pretty much just wanted to know.
I don't even know what this is.
I have a quick question. You had told us one time about what tenses we're supposed to write in, or tense. It's always present, right? Or
I think in this case it makes more sense to do it in past tense because she doesn't work there anymore.
yeah.
Pay attention to whatever their tense is in the question that they give you.
Okay.
Just make sure you use the same tense.
Okay.
Because if you use a different tense than what they use, they're going to be pretty upset about that. Okay, there we go. So, in court, they just wanted to see, does she have the same death rate as the hospital or no? So, if she's not really killing people on purpose, then she's going to have the same death rate as the hospital. Okay, so that's going to be our null. Our null is that pi is equal to, so Gilbert's death rate is the same as the hospital. Based on the data that you're given, what is the death rate of the hospital?
74, 16, 41.
Okay, so in total, 74 people died out of the 1,641 patients. Okay, and then the alternative is going to be that pi is greater than 74 out of 1,641. So Gilbert has a higher death rate. Okay, so not only in symbols, but you need to say what this means in words. So for the alternative, this is going to mean that Gilbert has the same death rate as the hospital.
This was a true story, right?
Yeah. Yes. So we're going to do everything and then talk about what happened in the end.
Your magic.
Yes.
Is that one that greater? She has a greater death.
Yes. Man. Okay, sorry. Yes. Okay, so Gilbert has a greater death rate than the hospital. So then our null is that she does not have a greater death rate than the hospital. Remember that it's not really an equal sign, it's like a less than or equal to. So Gilbert does not have a greater death rate. Okay. So that's the pH. Now we go on to the A, which is the assumptions. First assumption is the same assumption that we always check. What's that one? Random sample. Okay. So in this case, that would mean, did Gilbert get a random sample of patients? Do we know how she was assigned patients? No. Okay. So for a random sample, we're going to say not sure. Assume so. You guys remember the second assumption that we always check? Approximately normal sampling distribution. Do you remember how to check this for panic when it was for proportion? NP greater than or equal to 10, N1 minus P. We're going to do the same thing, except this time we're going to do N pi. So that's one of the big differences between a panic and a phantoms, is that we do N pi this time. Okay, and that's just because in a panic we don't have pi. We have no estimate of pi. So that's why we end up using P for a panic. So in this case, our sample size is what?
1600. No, it's not good.
Remember, we're only looking at Gilbert's patients.
257.
257. So you're going to do 257 times 74 over 1,641. Can somebody tell me what that is? Let me rephrase that. Everybody get out your calculator, please, because you're going to need it anyway.
11.59.
11.59, thank you. Okay, then we're going to have to do 257 times 1 minus 74 out of 1,641. Andy? Or anybody who has it?
245.41.
245.41.
Yes.
Okay, so we can say that the sampling distribution is approximately normal. Do you remember the third assumption that we check for proportion?
10% of the population.
Yep. Is my sample size less than 10% of the population size? So in this case, our sample size is 257. Do we know the population size? 1,641.
That's not right.
So we get 257 is less than 164.1. Okay, why do we have to check this?
It was done with
and without.
With or without replacement? Do you think they used with replacement or no replacement?
No,
replacement.
No replacement. This isn't met, so we're just gonna proceed with caution. I'm serious. That's what I want you to write. Proceed with caution.
Last one.
Okay, remember most of the time you're not going to have the population size. This just happens to be one of those weird cases when you actually have it. Okay. Oh my gosh. feel like this is gonna take us twice as long because it's a stupid pen.
Hey, you don't
You don't
have
have
to.
to write
Why aren't you
everything.
just write with
Yeah.
normal mark?
Like you can, some stuff is really quick and you just don't need to write it down. Oh wait, but this is being recorded, it's the most, right?
Right, yeah.
Oh.
Okay, so N is a little bit different. First thing you have to tell me is the name. So remember how it's called a large sample confidence interval for proportion? Well, this time it's called a large sample hypothesis test for population proportion.
Large saloon.
This thing is useless. Okay, next thing you have to tell me is the table. So, same table as before. Oh, no, I lied. No. Okay. Remember how for a panic for proportion, the formula uses Z, but we still use the T critical values table? Okay, this time you're using the standard normal table. Okay, next thing you have to tell me is before with panic you had to tell me 95%. This time you have to tell me alpha. Remember how with confidence intervals I told you if I don't tell you the confidence level you assume 95%? With a hypothesis test, if I don't tell you alpha, you're going to assume 0.05. Okay, and then the last thing that you have to tell me is the number of tails on the test. And that all depends on your alternative. So this right here, because it's a greater than, means we have an upper tailed test. Okay, so for example, if it was less than, that would be lower tailed. If it was not equal to, that would be two tailed. So it's either upper tailed, lower tailed, or two tailed. Okay. Are you guys going to remember this if I erase everything? Since you have it all written down?
Yeah.
Sorry, doesn't work to tell you. Okay, so that was through through N. So now we have T, which is our test statistic. Basically, this is a Z-score. So it's going to be Z equals, we're going to do P minus pi all over square root of pi times 1 minus pi all over N. I expect to see that formula. I expect you to see U substitute. So our P in this case, did we ever talk about P?
No.
I don't think we did. What is the P in this case? What is the value of P?
40 over 257.
40 out of 257. So out of the 257 patients that Gilbert helped, 40 of them died. Minus 74 out of 1,641. Pi just comes from the null. Okay. See if you can put that in your calculator and get the correct answer. I have my answer, so tell me when you have yours. You have it?
Yeah.
I got it.
8.54.
What did you get?
8.54.
Holy cow.
Really?
Yeah.
Okay, somebody else do it, because that's not what I got.
I got 21.58.
That's what I got. I got 21.58.
Oh my god.
Can anybody verify besides Karina?
I got 20.
Thank you. Don't just sit there and stare at me, Evan.
You're pulling.
Okay, 21.58. Do you guys know how to put this in your calculator? Okay, figure it out right now.
Oh, I see that. I'm good.
Okay, you're good?
Good.
Okay, guys, basically, you just have to put a lot of parentheses.
Yeah.
Like, that's kind of the whole key to everything. This should have been in parentheses, this part right here. Remember how I said be cooperative?
Here we go.
So put that in parentheses and then everything in the denominator just like it looks. Okay, next thing. So that's T. Okay,
41.
so we're not done yet. But this number is called the test statistic. So maybe write that down. Camila?
I just have a question. Why did we use 1,641 instead of 257?
That's what I was.
Oh.
wondering.
Yeah.
Nobody said anything until now.
Well, that's.
You guys trust me too much.
So was my answer right?
I don't know.
Says the one who said ha.
Okay, because that was my mistake.
Camila, we used 1,641 because I made a mistake.
Oh, sorry.
8.54.
You both
I
got
got
it
that
wrong.
with the negative number.
Wait, I still got the wrong. Okay.
Okay. So, do you guys see the mistake I made? That the sample size is 257. I'm not looking at everyone in the hospital, just Gilbert's patients. Okay, so that ends up being 8.54. So that's the test statistic. So then what we do from here is we're going to calculate a probability. We're going to do that in a minute. Let's do the figure first. Okay, so for O, you're going to be drawing a normal curve. Okay, so this curve is the sampling distribution of P. So first thing that you want to do is put the standard normal labels. So I have 0, 1, 2, 3, -1, -2, -3, etc. Okay, now 74 out of 1,641, that's what we're assuming pi to be. So that's 0.045. Okay, so 0.045. The standard deviation that we're going to use on the standard normal curve is all of that stuff in the denominator. Which is about 0.01. So this is going to be 0.055, 0.065. I'm severely rounding, but I don't have that much room, so. Okay, now the other thing that you're going to put on the curve is this test statistic. So Gilbert's death rate is at 8.41, so just approximate where that is. Okay, and that corresponds to a sample proportion of 40 out of 257. Okay, so because we're testing greater than, remember how we talked about how in a continuous curve you never calculate a probability at one specific point? How it has to be a range?
Mm-hmm.
Okay, because the alternative is greater than, you're going to calculate the probability of that and everything greater than it. So that goes back to this T part. I want to find the probability of Z greater than or equal to 8.41? Okay, you should be able to do that in your head without even calculating it. Zero. So this is what this is telling us. Assuming that our null is true, so this is the true death rate for Gilbert, the probability of getting a sample death rate of this size is pretty much impossible. What does that tell us about Gilbert?
Guilty.
Do you think she's a nice, sweet nurse? She's going at the slammer. Okay,
More than the slam.
can I erase this?
On that box, that square.
Yes? Okay, we're almost done, so stick with me. Okay, so that was T-O, so now we're on to M. Okay, M is where we make our decision. Now the way you make your decision is you take that probability and you compare it to alpha. So our probability is 0. That is less than 0.05. If your probability is less than alpha, that says I'm going to reject the null. So that's the M part. Oh man. Okay, we're almost done. S is the last part. Like panic, S is going to have 2 sentences. So the first sentence is going to interpret what does this rejecting mean. The second sentence is going to interpret what does this 0 mean. So we're going to say we reject the null. And instead believe that Gilbert's death rate is higher than the hospital's. So I'm going to say we believe that pi is greater than 74 out of 1,641. Okay, so that is just explaining what does it mean that we reject the null. Now I'm going to explain this 0 part. So the 0 means assuming the null is true, the probability of obtaining our sample statistic or one more extreme, is approximately 0. Okay, so then you're going to say this is very rare. So we doubt the initial claim. Okay, does that make sense what these 2 sentences are saying, this last part? If our null was true, this would be the probability of getting the sample statistic that we got. Because that's so small, we think that our null is not true. We question the claim of the null. Yeah? Okay. That is a phantoms problem. Questions? Okay, this is one of those problems that you're just going to have to get practice with. Are you guys curious as to what happened? I don't remember all the details, so we're going to have to look them up. I do remember though, so they actually did the same hypothesis testing court that we just did, but it was thrown out. Why? Any ideas why they would not have taken this?